Hi, this is Ricky Johnson with Microchip Technology. This tutorial will clarify some common issues that new click users encounter when using the MPLAB Code Configurator. For this tutorial, we will be using the Light Ranger click board. The Light Ranger calculates distance by measuring the time it takes for a photon to travel to the nearest object and back. We will read these distance values through a terminal emulator. We will also cover some common problems when it comes to setting up your clickboard. Hopefully this tutorial can serve as a general setup guide for all of your future click projects. Let's get started. We are starting off with an open MPLAB Express project configured to use the MPLAB Express development board populated with the PIC 16F18855 and the MPLAB Code Configurator plugin open. We are going to import the Light Ranger module. Navigate to Device Resources. From there, double-click on the Light Ranger module and add it to the project resources. If you take a look at the Information tab, you will see a link to the Microelectronica website. This website provides great documentation and schematics for your clickboard. It also provides examples. However, these examples can only be compiled with Microelectronica's compilers. To find examples that are compatible with MPLAB Code Configurator or MPLAB Express, please navigate to the MPLAB Express website. For this tutorial, we will be generating an example for the Light Ranger. Navigate to the Configuration tab to verify that the Generate Example checkbox is checked. In this generated example, printf statements are used to display the Light Ranger sensor readings. We will view these readings through a terminal emulator. Anytime printf statements are used, a USART peripheral will need to be added in order to utilize serial communication due to the fact that this is not automatically added. Double-click on this peripheral to add it to the project resources. Additionally, the Redirect STDIO to USART box will need to be checked to allow printf statements to be added in code. This is necessary so that the generated code includes the necessary standard I/O library. We will leave everything else as the default settings except for the pin assignments. When modules are added to the project, you will notice that the peripheral signals will need to be changed to work with your hardware configurations. Different boards and peripherals require different unique connections. Therefore, we need to set these connections ourselves based on the board and peripheral that we are using. For every clickboard, there are labels on each pin. These labels can be matched to the corresponding pins on the Express board. In this case, the EN pin should be connected to RB2, INT should be connected to RC2, SCL should be connected to RC4, and SDA should be connected to RC3. Through doing this, we ensure that we are connecting the correct signals to the correct pins on the Express board. Additionally, the RC0 pin is used as the transmit pin for the USART peripherals. We need to lock the RC0 pin to the TX signal. The PIC 18LF25K0, which also populates the Express board, is programmed to convert UART data to the USB protocol so that we can communicate with our computer. This will result in us being able to see the data that is being output from the Light Ranger in our terminal emulator. You can look at the Express board schematic located in the Document section at the bottom of the Express homepage to see how the PIC 16F18855 pins connect to various components on the Express board. Remember to always check the pin configurations to ensure correctness. The orange and yellow pins indicate that there are limitations to which signals can share a single pin. Therefore, you may get an error while trying to connect certain pin configurations. If this occurs, simply click a pin further away from the currently locked pin. You will see the previously locked pin release. After doing this, you should be able to connect your target pin correctly. Now that we are finished with MCC, click the Generate button and navigate to the Express IDE. In the project, you should see a new generated file including a main.c file. Click into the Light Ranger example.c file. You will see a read range function which prints out the data from the Light Ranger sensor. If you are ever unsure of what the generated example does, come to the example.c file to see what code will be executed. Navigate to your main.c file. You will need to include the example header file here. As a rule of thumb, anytime a MCC generated example is being run, you will need to bring in the appropriate example.h file. If you don't, you may get an error saying that you have conflicting definitions for a variable. Next, call the example function in the main.c file. Now you can compile and download the program. If successful, you should see a .hex file downloaded in your browser. Drag this file onto your connected Express board to program it. Lastly, we need to set up a terminal emulator to see the data. In this tutorial, I am using a program called CoolTerm. Before connecting, navigate to the terminal settings and make sure that you have the correct COM port selected for your computer. Your port will probably differ from mine. Ensure that the baud rate is set to 9600. If unsure about what COM port you need to connect to, this information can be found on your computer's device manager under the port section if you are using a Windows machine. Finally, click Connect and you should see the Light Ranger data being output. This tutorial provides the steps to set up the Light Ranger sensor. However, these same basic steps and tips can be used to set up any clickboard that uses these peripherals. I hope that you found this video helpful and informative. I'm Ricky Johnson from Microchip Technology. Thank you for watching.